So this is my first technical video I'm going to do on the Linux process tree and processes in general. So I want to cover a whole bunch of things such as multi-threading stuff, running jobs in the background, running stuff in the foreground, GUI based spawning and spawning off the root and spawning off your bash shell and all sorts of stuff. Also, I want to cover process prioritization and running processes and coming back to them. So I hope you find this informative. If you're a Mac user, some of this stuff will work, some of it won't. If you're a Linux user, hopefully most of it will work. I'm using SUSE Linux. I'm really impressed with their new desktop for Leap, SUSE Leap. So that's the environment I'm going to be working in. Where do I begin? Right, so I guess the first thing I want to talk about is this command, ps. Just run by itself. It gives you the processes that you're running in your shell, but you can pretty much find all the processes, and this ff command here gives it all in a nice process tree. Okay, so whereas these little symbols here, the dangle sort of symbols, represent a spawn. So what a spawn is each process will fire off something and have sort of child processes. If their parent process dies, then so does the child process. So if you're running Apache, some of those might have a whole bunch of Apache worker threads which dangle off the Apache master process. Okay, and we'll look more into some pretty good examples of this. Just while I'm here, there is one thing I just want to talk to you about, is this special process here. So this number one is systemd, okay, and this is the system that's used in modern Red Hat and SUSE. Ubuntu has a different system1 process, presumably Mac does, I'm not sure, but this system is the be-all and end-all ID, where everything is spawned off this. Now, I did have just a little, I should have opened this previously. Okay, so this is how it is in reality. So you've got process 1, which has process 2, 3, 4, 5 and whatnot all dangling off it, and then you have process 2, 3, 7, 4 dangling off process 2, for example. So we can see here, this BTRF and all these ones are all dangling off this process here called kthread. Whereas the root process seems to be on the same level as all the others, or these ones at least, when in actual fact it's not. So it's represented in this command like that, right? But in reality, everything spawns off process 1. Now you might be asking, well, what happens if process 1 dies, then everything else dies with it? That's a good question. The thing is, you can't kill process 1. It just will not respond to a kill signal, okay? It just ignores it and says, no, not going to do what you say. So that is hard-coded within somewhere in Linux. You cannot kill number 1. Okay, so I guess the next thing is talking about the jobs command. So jobs tells us all the jobs we are running in a current shell. Now, might seem a bit pointless here in a GUI, but when I'm working in business and industry, I don't use a Linux GUI. All my work is done in the prompt, so they've got nice sort of commands that help you manage stuff that you spawn off your command shell. So where's a good sort of example, I guess, is what I might do is run I created actually I'll just remove this file here and this one here, because I did practice this before I made the video. I created this SUSE no freeze ISO here. That's just with the dd command. This time I am going to create it again. I've just removed this file here, so if I do ls, I'm going to create it again from my CD-ROM. So I've got the SUSE installation CD. It was a net install, so it'll be very quick. SUSE ISO, and let's create this now. So I'm going to Control Z, right? And what that does is stops that ISO creation process just then. So it was starting to read the DVD-ROM, it's stopped now. If I click on jobs, okay, I have one stopped process that is this dd command. Okay, now if I put that process back into the foreground with the fg command, I can do that, and bang, there it is. And if you were here right now, you would see or hear my CD-ROM is physically firing up and going crazy and generating this ISO image. Okay, so that is how you can freeze a process with Control Z, and then you can put it back into the foreground, and it works as good as new. Obviously, don't make a practice of that, but obviously, if you have a use case to sort of stop a process midway, then by all means do it. Now, this shouldn't take too long. Okay, we have created an ISO image with when we stop the process halfway through. Okay, so if I create just to do a I'll do an MD5 sum of the ISO I just made plus the one I prepared earlier, which was done completely in one go. It's exactly the same. Even though I stopped that process and came back to it, it's all there. So just to really prove it that this is actually working, is I will mount this to my file system, just in this directory, the MNT directory. Okay, it's mounted read-only, which is fine because it's an ISO image, and there it is. So I'll just cat a random file, and it's fine. So let me cd out of that, umount mnt. Okay, sudo. Okay, so back to my home directory. Great. So now let's talk about spawning multiple processes. And I think the best way to contextualize this is actually using the GUI and the command line. So I can actually spawn GUI processes off the command line, which is kind of cool. Now, if I add a ampersand at the end of my command, it keeps the process running and gives me back my prompt. So if I run this awesome application called xargs with no ampersand, there it is, and the focus is on this uh, this little xargs application. I'm going to Control C that, not Control Z it, which will actually terminate it. Okay, now I'm going to start running stuff in the background. 1, 2, whoops, 3. Okay, and then if I say jobs, okay, I've got all these running in the job, and they're all spawned off my shell. I'll run as well Dolphin, which is a file manager. Okay, there it is. Alright, and now I've got a whole bunch of eyes looking at me. So split vertically and create a new shell. If I look at this and how it's all rendering, so I'll just grep for my bash because I know I'm using the bash shell. Okay, and what I've got here is, okay, this is my terminal called Terminator. Okay, there's another process here that's probably got something to do with the GUI. Okay, and then this Terminator program spawns off bin bash, okay, which is the shell, which is this one here. Okay, and then spawned off that are 3 instances of xeyes and 1 dolphin, which is, where did I minimized it? Where's it gone? There it is. Okay, so these are all spawned. Now what would happen, of course, if I close this shell effectively, or this Terminator one up higher, I will close everything else as well. Incidentally, this one here, this bash interpreter, is this window here. This bash interpreter is this window here, because when this process command was run, I was running the process command. If I just click up arrow, and the grep bash c10, and that was my last command there. So psauxff and this one here were running in unison. Okay, so some pretty cool things what you can do with processes. There are some reserved. You can kill them for starters, which is, who cares, right? So I could find out the process of these xeyes. So xeyes, this one, the second one, is 5239. So let's just kill that. Bam. There he goes. Because I don't want to do that, I can just run up, use the jobs command, the jobs reference with percents. Okay, so kill %3 killed the third job, rather than me having to look up what was process. It was 524 ID, 5242 rather. So I can just use the % command. The other thing that's kind of cool is if I want, I can get the process listing of these various jobs that are there. So this one would be Dolphin, this one would be xeyes. So if I look at xeyes, it's 5236. Dolphin is 5255. So yeah, there are various ways that I can kill processes. Now, here's just some other things. So kill, I think, is named rather badly. What it really is sending signals to processes, and it's called kill because mostly, 95% of the time, you're going to want to kill processes with this command. So, but you can do other things. So notice that the eyes are watching me. Okay, so let's stop process number 1, which is 5236. Okay, And look, I've frozen xeyes. It can't move because the process is stopped. Now I can send a different signal to it. I'll say, look, I actually want you to continue. Bang! Hey, I'm alive again. So stop and continue are just some of the commands that you can set to these sorts of commands. Let's just try something else. Okay, so let's run up another few instances of xeyes. And I want to demonstrate this whole spawning thing. So when I close, as we can see, this instance of Terminator is spawning these two shells plus these three eyes plus this dolphin. So I'm going to close this, and all of them close because the parent processor was the parent process was killed. Okay, so let's go bring up an instance of Terminator again. And what we'll do now is run another 3 instances of xeyes. 1, 2, I can just press up arrow, 3. Okay, now, what was I going to show you? In fact, let me, sets ID is xeyes, sets ID. So by default, this, as I mentioned, will spawn these, the ones with sets ID with no other argument passed, will spawn these two off the root, that system D process number 1, which is the top of the hierarchy. So if I go ps aux ff grep xi c10, okay, what I've found is that there are these 2 lone xis down here, which corresponds to the last 2 that I've run, this one and this one, and these other 3 should be spawning off here because I didn't put sets ID on it, so they've just spawned off the bash. Now, quite frankly, I prefer this when I'm opening up a file browser. I don't like it generally to close on me when I close my prompt, right? xeyes, I don't care, it's just like a training utility. So I close that. Anything that wasn't given sets ID will close because it spawned off the bash prompt. Okay, now to manually close these. They don't seem to... Haha. Oh no, there we go. Cool. Alright. Now, okay, so that's sort of process spawning and how to control things from the tree and putting things in background and putting things in foreground. I also want to talk to you now about resource prioritization. So there's a cool utility called htop, and it lists all the processes here, okay, and how nice they are. And if a process is nice, it's going to say, well, look, to the other processes, I'm going to give you CPU cycles when they come around because I'm a nice process. If I'm not nice, then I'm going to hog any processing that I get. Okay, so I'm going to be an unnice process, and I'll just see if we can see here we have some processes set to -4 because they're not very nice. So the audit D, whatever this does, gets more priority over my Firefox application, for example. So, but what I can do here is say nice 5 xeyes. Okay, and what I might do is put that in the background. Okay, and let's do a nice -15, make this really not nice. Okay, so the way to think of it is the lower the number, the less nice it is, which means the more aggressive it is. Okay, and totally aggressive, this instance of xeyes gets priority over anything else on my system. Okay, now you'd never do that in reality, because this is doesn't use that much CPU, it's not that bad. A really good use case of when you would put something to be really nice is like a backup script, because that uses a lot of CPU perhaps and disk IO. You don't want those resources being prioritized over a service that you're giving, like a web page. So you want that web page to run flawlessly during your backups. So you IO nice it and you nice it so that it doesn't get any of the precious CPU cycles. Your users have a flawless experience, and your backups work. Generally, you might have a 20-second backup delay, but who really cares? It's better than that than having your users having a 5-second lag on their website. Okay, so incidentally, there is IO nice. So this one is all about CPU. This one is all about disk access. So if I go top, okay, whoops, I'll go to htop. I like it more. Hopefully we can see the xeyes flash up. There it is. That one was the really nice one. Okay, it's and maybe we'll find the other ones lingering around. Maybe if I move them about a bit, they'll use a bit of CPU and come up, but doesn't look like they use too much. Okay, so take my word for it. We I guess I can look here as well. Probably has the nice values of xis, and no, I don't think it does. Okay, but in any case, that's how you nicer process. There is renice as well. You can set like change the priority. So I'll go n. Let's just get the process IDs of these things. Okay, and I'm going to go renice, and I'm going to make them all really, really nice. So um, the highest niceness that something can be is 19, and the lowest is -20. Okay, old priority 5, new priority 19. So now these xeyes applications are going to be put after everything else. Okay, so renice 19. Okay, and they're still working because they use bugger all CPU and resources. They're actually a really nice little training utility, I think, because they respond quite well to sort of calls and whatnot. Okay, so that's that. Now I'll just close that because that's the easiest way to close all those applications. Now I thought we'd do a bit of scripting because I wanted to discuss how to parallelize or multi-thread jobs, and it's kind of cool. We can play around with a few more signals as well. So let me split the screen and we'll write a script first. So what I'm going to do is say for I in sec1100 do echo I. I'll step you through this script. Sleep 1 done. Okay, so what this does is just puts out the numbers 1 to 100 with a sleep, 1 second sleep. So this command here, sec, just generates numbers from 1 to 100. Okay, and these things here evaluate that. So it's basically saying for I in 1, space 2, space 3, space 4, space 5, all the way to 100. Okay, and then I iterate through this loop, and that's pretty much it. Okay, so what we can do now is press the up arrow. It gives us, it's in a nice little concise one-liner, and I'm going to create a my script. In fact, I think I did this too. Yeah, I'll just delete that and create the new one. Okay, so the first line here says what command interpreter I'm using. I'm going to be using Bash. It's an interpreted language. I could use Python, I could use Perl, or any of those other ones, Ruby. So effectively this just tells Linux where do I look for the binary that it can interpret the script after this. It's a preprocessor, it's called, sort of treated as a comment, doesn't actually affect the code aside from loading up the program that will interpret that code. Okay, so I'll give that executable permissions. Bam. And let's run that. That's my script. Cool, now we have a script. Okay, all pretty easy. One last thing, let's just change that one bit, and we are going to make that accept a input variable, the first input variable. So if I say input 3, it'll say set for I in sec13 and do this echo statement and iterate through it 3 times. In addition, while I'm at it, why not, let's just echo the date as well. Okay, so backticks date will evaluate that date expression and give us the real date. Okay, so just so you know, there is a command called date. All right, same with sec 1, 2, 3. Okay, all these commands are just evaluated in my script. Okay, so let's run my script 3, and it's going to iterate 3 times. Whoop-de-doo. Cool, awesome. So that's done. Now let's do some cool stuff. Let's multi-thread this 100 times, or let's say 50 times, and each time we will iterate through it a little bit more. Okay, so I'll just show you what I'm going to do. We're going to generate our input variables. So we're going to just input 1 to 100. Now I could type a file and pass it into the command I'm about to do, or and just give it some maybe some random numbers or something. You know what? Let's do it slightly different. Okay, so what I've done here is I've increased the number by, so this is the first number, this is the what do you call it, the increaser, if you will. I don't know the right word for that, and then we're going right to 100. So we are going to generate around 50 numbers. Okay, bugger it, I'll go to 200. Okay, and then what we're going to do is parallel my script. We're going to run it in parallel, and we're going to tag it so we know what is the input variable that is given to it. And in addition to that, we are going to run this 50 times. 50 times. And in addition to that, we need to know the actual script, which is script sh. Let me just tab my script, I beg your pardon. Okay, so, alright, so I might not get this right straight off the bat, but generally speaking, when you play around with this command, keep your jobs low. Alright, this is using bugger all CPU, so we should be fine. Okay, so let's go. Bam. Okay, we get a bit of a copyright blurb, and then outside that, okay, it's passing 1 to this script, and then it's iterating through 1 times. It's passing 3. Now the reason why you're not seeing all this stuff all at once is that tag command makes sure that the output isn't interleaved, so it waits for one command to finish its output, then combines it. So let's have a look at this. This is kind of cool. Grep C, let's grep for bash, C 50. Boom. Look at this. Because I've called the script, okay, this is my window here, and then we've run the parallels written in Perl, okay, and you can see my tag and my job 50 and my script, and each one, this is what's running when I ran this command. 29, 31, 33, 35, 37. So I'm running this script all this many times. If I do a ps aux, I think it might have finished, maybe not, because it'll take longer to iterate through each time. Grep my script. Okay, that's what's running. If I do a line count on that, I've got roughly about 51 processes probably, because we can't include the actual grep that we've actually done. So that's 51 processes, and this is still going. Okay, I'm going to Control C this. Okay, Control C will kill the parent bash shell right at the top here and kill all these others. So now let's just make sure they're all gone. Okay, the only thing that's come is my actual search there. Okay, so I'm going to take the tag thing away, and we can actually see. This will probably give a better illustration of things running in parallel, because the tag statement really just keeps things nice and neat by making sure that all the text is not interleaved, right? So while all they're running at the same time, it'll say, okay, process 1 is finished, dump the text. Process 2 is finished, dump the text. Process 5 is finished, dump the text. And that's how it does it. But if I don't have that tag thing there, I'm not going to get what my input command is, but as well, it's also just going to just dump all the stuff as it finds it. Okay, again, copyright stuff. All right, now here we go. So we should see some mix up here. So it started off nice because the first process finished, and then look, all this jumbled sort of stuff all coming through as all the processes are running. And what I can also do now is use the kill signal to send some really cool commands to this. Where are they? Okay, let's do. Man, I can't even remember them. What are they? PS. I'll look in my history. Yes, kill. So I'm not actually killing it. All I'm doing is sending a custom signal. I should also find the process ID. Okay, kill sig user 2. I found this from the man page, and this is the process. Bam. Okay, what this does is, I don't know if you noticed, but before we didn't actually get a status of how far through we were through this parallelized jobs. So here we've started number, I think the way to read it is we are through, I think we're up to number 50, or there's a total of 50 jobs, maybe 38 of the way through, and yeah, I'm not sure what that 100% is. In tagged output, that gives a lot better output, but there you go. The point is, I wanted to illustrate that you can use kill and send processes different signals to do different things on the fly, which is pretty cool. There's another one here. I'll try this one. I haven't used it before. Kill USR1, and it might give us something interesting. Bam. Okay, so that just outputted. I sent the user one signal 14572, and it sent me, I don't know, I'll do it again. Okay, it sent me all the processes that were running at that time. Boom. Okay, there it is. Okay, so I can keep doing that and keep getting more output. Okay, I'm going to just close that because I think we're done. Okay, one final thing, because this is totally awesome, is screens, the concept of a screen. Let me just make sure that that parallel stuff is all gone. All gone, good. I'm going to clear my screen. Alright, so let's run one instance of my um, script, but first I'm going to open what's called a screen. Now the cool thing about a screen, without doing sets ID or anything like that, it's coded to always be at the top, much like an Apache daemon or something like that. It'll spawn off number 1. So see, 10. Boom. Okay, at the moment it doesn't look like it did, but bear with me, it should. Okay, so now I am going to run my script. Okay, and here it goes. Okay, I should really so run it 200, like iterate through 200 times, and away it goes. Okay, now because that's in a screen, I'm going to close that. Okay, and let's have a look. Okay, there's definitely a screen process running. Yes, there is. I've used screen ls, so list all my screens, type screen minus x, boom, I've got it back. So that is how I look at them as kind of like, Windows terminal servers. You can open a session, then you disconnect as opposed to logging off. You do your thing, you come back home or whatever, you VPN in, and everything's back the way it was. Well, same with screens. Okay, so screens are pretty cool. Though I'm pretty sure maybe it's moved itself up automatically. Let's have a look, because it can't be spawning off that bash shell anymore. So it should be. Interesting. Oh, screen X is, but do I have another one? I'm sure I must. Okay, I'm just going to close that because that screen will still be there. And let's try again. PSAUXFF grep screen. KC10. No, it seems to attach itself. Oh no, hold on. That's me searching for it. So that must be. I'm wondering. You know what? I don't even know which process it runs as screen. It could be that one. I don't think it is. It certainly doesn't look. Am I not seeing it? Maybe it's called something else. Anyhow, I'm pretty sure that runs at the actual root of the terminal. But in any case, just to let you know, this is how to keep processes alive if you really want to come back to them. It's the safest method. Come back, there it is. Okay, so screen minus X will show you if you've just got one screen open, you can have multiple screens open. Attach means you're attached to it now. I've just killed the process within this screen. And if you have multiple processes, screen minus X I think might take the first, or screen minus R, and then you just put in this string and you can attach to it. Anyway, so that's covered a whole bunch of stuff. The spawning trees, we've learned how to stop processes midway, start them, send different cool signals, spawn stuff off the base, spawn stuff off bash, foreground, background processes, prioritize them, and use screens. The only thing I need to now research is what's the actual process name of screen, because I didn't actually see it. And I'm sure as soon as I finish this video, maybe it's just video anxiety, I will see it straight up. But there it is. Okay, I hope you found this informative, and I plan to do many others. Thank you very much.